chips 8086 and 8088, the flag register was 16 bits long. With the 32-bit version of the chip, the register was expanded to 32 bits and is now called E-flags. But it's not a register like any of the others. It doesn't hold a number. It holds a collection of flag bits. The flags are all single bits, so you address the contents of this register one bit at a time. Extending it to 32 bits didn't really change the size of anything. It just added more flag bits. Various instructions will affect the flags in different ways, and remembering which flags are set or cleared by which instructions is just not possible. It's one of the main reasons that you need to have some sort of hardware reference to be able to write assembly language. A single instruction can set a number of these flags called condition codes and can clear others. So I can't give you a coherent list of which instructions set which flags, but I can give you a list of flags so you'll have an idea of what you're dealing with. Each flag has a two-letter signifier which is derived from its name. For example, OF is the overflow flag. This flag is set when the result of an operation is too big to fit the location specified for it. It means some data has been lost and the answer isn't all it could be. The sign flag is set when the result of an operation is negative. It only means that in the result, the highest order bit is set to 1. If a result is positive, this flag is cleared. In assembly language, you don't have less than or greater than comparisons. You just subtract the two values and check the sign flag. You'll actually use this more than you think. The 0 flag is another one you use a lot. It gets set when the results from an operation is 0. To compare two numbers for being equal, you subtract them and check this flag. If the result isn't 0, meaning the two are not equal, this flag is cleared. This is everyone's favorite. The carry flag is the most useful one of the bunch. If the results of any arithmetic operation, shift or whatever, has a leftover carry bit, this flag is set. If nothing is carried out of the operation, then this flag is cleared. This flag is different. This flag is one that you set to modify the way that certain instructions behave. Here's a simplified explanation. One instruction can be used to copy a block of memory from one location to another. With a DF flag set, the copy will start at the highest memory location and proceed through to the lowest. If DF is not set, the same instruction will begin with the lowest memory location and loop through them all to the highest. You can see how this would matter if the two blocks overlap one another. Otherwise, who cares? This flag can be set or cleared by you, and it may be set or cleared by the CPU under certain conditions. If it is set, interrupts are enabled and can occur at any time. When it's not set, interrupts are ignored. The trap flag is something that you will probably never use. With this flag set, the CPU will only execute a single instruction before it calls an interrupt routine. This is used by debuggers to make it possible to step through a program one instruction at a time. This is pretty advanced stuff, and I promise I won't talk about this flag again. The auxiliary carry flag is used for a special form of arithmetic that isn't used much anymore. It works with BCD, binary coded decimal numbers. BCD is a way of encoding base 10 digits 2 to a byte, but it isn't done much anymore. It was big with languages like COBOL and RPG. One more, the parity flag. It is set if the number of bits set to 1 in the low order byte of a result is odd. If the number of bits set is even, it's cleared. At one time, parity bits were important to data communications, but that's not done much anymore. There are some other flags, but believe me, you care even less about them than you do about some of these. For instance, there are two flags that only have meaning for the 80286 CPU. Also, Take the descriptions I gave you with a grain of salt. The only way you can work with these flags is one instruction at a time. You'll have to check which flags are set and why for the individual instructions. For example, some instructions that result in 0 will set the ZF flag, while others won't.